Okay, photochemistry. Now the question is arises, can psi having the value greater than 1? So there the answer is yes. The value of psi that can be more than 1, but in some special cases. Normally for any photochemical process, psi should be less equal 1. Maybe less than 1, maybe equal to 1. If the laws of photochemistry are correct, the quantum yield should be unity. Means photochemical all laws if are accurately maintained, so normally we get phi equal to, not psi, phi equal to 1. That is photochemical yield equal to 1. But actually this is very rare. As we know from gaseous concept, normally we detail study about the ideal gas concept. PV equal to nRT. Okay, for 1 mole of gas we derive the equation PV equal to RT. But actually most of all the gases are behaves like as real gases in normal condition. At some specific condition they act as ideal gases. Normally they are exist as real gases. So that means the ideal concept is not so much important in real sense. Similar things that should be rare. So there is lots of reason due to low yield. First one, excited molecules may get deactivated before they form products. When any incident radiation that should be incident in some molecules or particle, there should be absorption of some amount of energy, molecules get excited and by this way they react and produce product, right? But if there is any kind of deactivation before the product formation can be take place, so obviously energy decrease, so chemical yield also decrease, so phi less than 1. Okay. As for example, for any candidate who are prepared for some competitive exam, when they having low confidence and due to this they do not give their 100% performance, so they are obviously that their marks that should be deducted, that should be decreased. Okay, second one, collision of excited molecules with non-excited molecules may cause the former to lose energy. If molecules they are excited and they ready to produce product, but before this they collide with some non-excited molecules, by this way energy exchange, so overall energy of the excited molecule decreased, so chemical yield that should be decreased. So phi also on that case less than 1. Similar type of analogy when we prepare ourselves for any studies, so when we see any kind of student who are not prepared well or who are not seriously taken this matter, so our confidence that should be decreased. Similar analogy. Third one, the primary photochemical process may get reversed. Sometimes the reaction which are occur, this reaction can also be reversed. By this way chemical yield that should be decreased. Fourth one, the dissociated fragment may recombine to form the original molecule. Sometimes the dissociated molecule they recombine and produce the original molecule, that is the starting molecule. So by this way, by this 4-way product formation does not take place, so chemical yield if take place, this is the yield is very low. Okay. Now we consider when phi is greater than 1. But in some cases molecule activated photochemically and initiate a series of thermal reaction called they are secondary reaction or secondary processes in which the excited atoms or free radicals that should be produced and they initiate so many reaction. In the primary stage they react further giving higher quantum yields. Suppose if there must be some radical initiated and that should be proceed series of reaction. Okay, by this way so many product formation can be take place. On that time chemical yield greater than 1 can be occur. Okay, so the first reaction where the radical produced that should be primary reaction and there should be series of reaction can be taken place. This series of reaction are termed as secondary reaction. Now we consider sometimes the atoms or free radicals initiate a series of chain reaction, like as for example in the combination of H2 and Cl2 to give HCl, when resulting quantum yield that should be 10 to the power 6 or more, that should be higher value, 10 to the power 6 or more, unexpectedly higher value. Okay. If the secondary reaction is exothermic, if heat is released, exothermic means heat is released. So the heat of reaction may activate the other molecules, thereby causing them to react. Suppose there should be, for initiation we have to provide some heat, but the reaction is exothermic, so the provided heat can be sufficient to produce a series of secondary reaction. That's why overall chemical yield greater than 1. Okay, and this is another reason for higher quantum yield. As for example, acetone phi equal to 1 when H nu lambda is greater than 266 nanometer. I introduce lambda when increase energy that should be decreased. As we know, energy that should be inversely proportional to lambda wavelength. Okay, so that should be produce some radical activated species. That should be produced again CH3 radical plus CH3 CO radical. Okay. Similarly, when CH3 CO CH3 acetone H nu that should be lambda less than 193 nanometer means its energy is high. Okay, lambda decreased means energy correspondingly increased. So it should be dissociated, produce CH3 whole twice CO radical and 2 CH3 and plus CO. Now we consider, broadly speaking, the total energy of a molecule according to the Born-Oppenheimer approximation. Born-Oppenheimer approximation directed the overall energy, the total energy. Total energy that should be the sum of all of the energy, like for example, transitional energy plus rotational energy plus vibrational energy, and last and least that should be electronic energy. Always remember the value of electronic energy, E electronic, that should be higher than E vibrational. E vibration that should be greater than E rotation. E rotation is greater than E transitional. Okay, the value of electronic energy that should be higher than vibration energy, vibration energy that should be higher than rotation energy, and rotational energy that should be higher than transitional energy. Okay, why we can say this is the reason behind of it, because electronic energy consists of so many vibration level energy. Okay, so vibration energy level that should be consist of so many rotational energy level, and rotational energy level that should be consist of so many transitional energy level. So that's why electronic energy is highest value, then vibration, then rotational, last one transitional. Okay, the energy is the sum of transitional energy ETR, rotational energy E rot, vibration energy E vibe, and electron energy E suffix EL. The transition energy is however not quantized. Quantized means for a specific energy state, when molecule goes first one to second one, it definitely absorbs some amount of fixed energy. Suppose if a molecule exists in ground state and it should be go to first excited state, the value is fixed for 12 kilojoule energy. Okay, so we have to the molecule should be absorb 12 kilojoule exact, not it absorb 10 kilojoule, below 12 kilojoule, and not it absorb 13 kilojoule. It always absorb 12 kilojoule, then it transmitted to excited state. Otherwise, they are not able to transmit in excited state. As for example, when you go in a specific place, you have to go for a specific station. If you go before the station, you have to carry some car or have to carry some medium. By this way, you can approach this accurate place, right? And when you pass this station and after suppose you go Malda station and you take up you go actually in Dalkula station, you have to go Dalkula to Malda again, right? Suppose you have to go Malda station, but you take off in Kolkata station. You have to go again Kolkata to Malda because your destiny is Malda. Okay, similar things. Now we consider as E transition energy is not quantized, so we can say energy equal to sum of E rotational energy plus E vibration energy plus E electronic energy. Okay. Now let us illustrate this energy with reference to a diatomic molecule. Rotation energy arises when the molecule rotates about its axis perpendicular to the internucleus axis and passing through the center of gravity of the molecule. There should be some rotation about the axis can be there. That's why the molecule exhibit rotational energy. Now we consider electronic transition. Electron transition means what? That is molecule electron transition take place when electrons in a molecule that should be excited due to incident radiation and from one energy level to high energy level, right? Electronic transition occurs in atoms and molecules due to the absorption or emission of electromagnetic radiation specifically for UV or visible region. Always remember electromagnetic radiation are basically two types. One is absorption radiation, other is emission radiation. Okay. The energy change associated with the transition is related to the frequency of electromagnetic wave by Planck's equation. By this way, we can say E equal to h nu because energy is directly proportional to nu frequency. So E equal to h nu. That is the Planck's equation. Now consider this molecule is a ground state. When it goes to N to pi star absorption, it got to activated. Okay. Always remember epsilon max. Epsilon is the intensity. When epsilon max is greater than 0, that means allowed transition. When epsilon max less than 0, that is less than 0, that is almost negative value. So that should be forbidden transition. Okay. Now we have to know some energy diagram. Always remember when we consider mode diagram or we have to consider the electronic excitation of ions, molecules or electrons, we have to consider some terminology. As for example, this is the bonding orbitals BO and this is the anti-bonding orbitals. Okay, the middle portion is non-bonding orbitals. Now consider this is sigma, this is pi and this is NB non-bonding and this is corresponding excited state pi star and this should be sigma star. Okay. Now last one topic, that is singlet, that is the difference between the singlet state and triplet state. Singlet state, that should be singlet state of the system has 2 electrons, one in ground state, okay, the other in high energy state of spin unstable. Suppose in one electron exhibit in ground state, other electron exhibit in excited state. That should be called singlet excited state, not only singlet state, that should be called singlet excited state. Okay. Now triplet excited state. Triplet state has 2 electrons, one in ground state, other is higher state. Okay, but spin that should be changed. What is the difference? That is singlet state actually one ground state having 2 electron. Okay, but when get excited they convert into singlet excited state and triplet excited state. Here we consider the excited states, that should be singlet excited state and triplet excited state. Singlet excited state having 1 electron in ground state and other electron in excited state, but their spin that should not be changed. Okay, triplet excited state 1 electron in ground state, other electron in excited state, but their spin that should be changed. Suppose singlet excited state spins are anti-parallel, like for example this is. Spins are not changed, but here spin that should be changed. Okay, this. Singlet excited state lifetime 10 to the power minus 9 to 10 to the power minus 5 and triplet excited state, that is the time lifetime 10 to the power minus 5 to 10 to the power minus 3 seconds. Means the lifetime of triplet excited state that should be higher than singlet excited state. Now consider stability. Singlet state are less stable and shorter lived. Okay, triplet state that should be more stable and longer lived. Energy, singlet state higher in energy and triplet state that should be lower in energy. And singlet state magnetism, it is diamagnetic as it has no unpaired electron. Actually, there is no unpaired electron. And triplet state, it is paramagnetic as it has two unpaired electron. That should be there because there should be spin unchanged. So there must be two unpaired electrons. Their spin are not cancelled to each other for triplet excited state. Okay. Magnetism, okay, radical. Singlets are no radical. Triplet can be, we say, biradical, but this is not correct. Now singlet state, total spin half minus half 0, because one orientation that should be exhibit this, other exhibit this. Okay, so by this way that is plus half and that should be minus half. Due to this we get overall value 0. Spin multiplicity 2 into 0 plus 1, that is 1. Now we consider triplet state, that is must be s equal to plus half minus half, because one direction is of this, direction is this. If this is plus half, this should be the plus half value. So we get plus half 1 value. Spin multiplicity 2s plus 1, that should be 2 into 1 plus 1, that should be ultimately we get 3 value. Okay. So what are the summary of the whole the study? First one, that is phi value may be greater than 1 when in special some cases when there should be primary reaction. During primary reaction some radical can be produced and this radical can be generated series of secondary chemical reaction, and due to this chemical yield increases. Suppose H2 and Cl2 to produce HCl, there should be lots of radical formation. By this way secondary reaction can be take place. Okay. Second reason, sometimes the process is exothermic heat that should be released, but what amount of heat that should be we introduce, this amount of heat can be able to produce secondary reaction. So due to this phi that should be increases. Phi decreases when there should be before product formation the molecule get deactivated. Before product formation excited molecule collide with non-excited molecule and primary photochemical reaction get reversed and the dissociated fragment again recombine to produce original compound. By this way phi that should be less than 1. But normally if we accurately follow all the photochemical laws, phi will be 1 unity, but that should be rare. Okay. Born Oppenheimer approximation, that should be called, that is the total energy equal to E transition energy plus E rotation energy, E vibration energy plus E electron energy. As we know E transition energy is quantized, so we can say total energy equal to E rotation energy, E vibration energy, E electron energy. Rotation energy due to rotation of the molecule, that should be generated. Vibration, that should be due to vibration of the molecule generated. And electronic transition, the energy generated is termed as electronic energy. Now we consider electronic transition due to absorption or emission electromagnetic radiation, molecule get excited and there should be electronic transition can be possible. And they are always saying about epsilon is the intensity. If epsilon max is greater than 0 means allowed transition, epsilon max less than 0 there should be forbidden transition. For MO or for electronic transition we have to consider, that is the low energy orbitals. Low energy MOs are termed as bonding MO and there should be higher energy MO are termed as anti-bonding MO. Okay. And their middle part there should be exhibit non-bonding. Okay. And due to their electron fulfillment we can establish bond order, bond length, bond strength and all of the properties. Okay. And last one, what we know from excited singlet state and excited triplet state. At first the electrons are all in ground state. After excitement they may exhibit excited singlet state or excited triplet state. This is the difference between singlet excited state and triplet excited state. First one, in singlet excited state and triplet excited state, both of the cases one electron exhibit in ground state, other electron exhibited in excited state, but difference is in singlet excited state spin that should be unchanged, and triplet excited state spin that should be changed. Due to spin unchanged singlet state, there should be diamagnetic properties, and there should be total spin half minus half 0, and spin velocity that should be 1. And triplet state, that should be overall paramagnetic, and there must be total spin plus half 1, and spin velocity that should be 3. And also singlet excited state, the lifetime that should be lower than triplet state, so that should be more energetic. Singlet excited state is more energetic and very much unstable and short-lived. Okay, so that is the summary. Okay.